if Nathan were to drink 1/2 of a bottle of cranberry juice per day, then the model that we would use to tell how many bottles he had drunk after 10 days, we would just simply multiply 1/2 times 10 for 10 days. So he would have had 5 bottles of cranberry juice. So a silly example, supposed to kind of be fun to help you get to think about this. This is an absolute change. Every day he drinks 1/2 of a bottle. Absolute change every single day. That rate of change, the slope is 1/2. If I said something like this, though, if he started with $100 and he makes 12% more per day, that's a relative change. That is an exponential function. So the setup for this is the initial amount would be my A, 100. My rate, if it's increasing, you're going to add 100% to that. So 112%. This represents that every single day Nathan's income is going up by 1.12, 112%. So 100 plus 12%, like that compound interest formula. And then how much would he have after 10 days? Well, we can plug 10 in for x, but here x is in the exponent. And that's going to give you the amount after 10 days. Exponential growth will grow far different than if we had linear growth. So keep that in mind. Discuss the difference between these two scenarios. So if the starting price of an item was $100 and it decreases by $3 per day, that is an absolute change. It's a number that you're decreasing per day. But it's just linear. So -3 would be your slope times x, how many days passed, plus the initial value. If the price of an item decreases by 3% each day, this is exponential growth. So your initial value goes where A went. I'm going to go back to this slide right here, and that's actually what I was trying to tie together. If I decrease by 3% each day, then right here you'll have 1 minus 3%, 100% minus 3%, and that gives you 0.97. So if you're decreasing, you're going to subtract that from 100%. And so that is why on this exercise 3, my setup, so initial value times my base is 97%. 97%. Every single day I multiply by the day before, the price the day before by 97%, and that's going to give you exponential decay. So earlier I talked about this. If the base is less than 1, then you're going to have exponential decay. This decays faster rate than linear. So linear would be a slope here of -3, whereas exponential decay, it is a transformation of exponential growth. This rotates around the x-axis, the growth curve. So now exponential decay decays at a faster rate than linear decaying would. Just to remind you, if the base is greater than 1, that is exponential growth, and if it's between 0 and 1, you'll have exponential decay.